Okay, so if you're, and these problems specifically tell you what form to use or what law to use, but if you have this information right here, you have two sides, okay, the angle is between those two sides. So if you were to sketch the triangle, you have ABC here. If side A is 57, angle B is 67, and side C is 60. So you see that you have this SAS pattern. SAS tells you you're going to use law of cosines. And so in this case, the unknown that we're going to solve for first is B. And B is opposite the angle B. And so we can set up law of cosines as the designated side, B squared is equal to the sum of the squares of the other two sides. So 57 squared plus 60 squared minus twice the product of those two sides times the cosine of the angle opposite B, which was 67 degrees. Okay. Now, this particular case is probably easiest to solve just using the solve feature of your calculator. Okay, you can manage it by hand too if you want, but I'm just going to use the solve feature here, and I'm going to use x instead of b. And I get x squared is equal to 57 squared plus 60 squared minus twice the product of 57 times 60, all times the cosine of the angle involved, 67. I'm going to enter a decimal, so my answer is displayed as a decimal, comma, x is the variable I chose. Okay, and so once I have that, I get my solution. In this case, notice it gives me a plus or a minus. I want the positive. So I get 64.625 as my solution, and it wanted 2 decimal places. So as I look at that, again, it is 64.63. So I'll round that to a 3. All right, once I have this measure, 64.63 approximately, what I can now do is I can go back and find either of the angles. And let's talk a little bit about the inverse sine and the inverse cosines. Okay? Or, I'm sorry, the inverse sines when we're dealing with that. Okay? If you use your calculator to find an angle whose sine is some given value, which quadrant does it give you the measure from? It gives you quadrant 1, right? But when you look at the sine, like angles that have the same sine exist in in quadrant 1 and what other quadrant? What other quadrant would have an angle with the exact same sine? 2, right? Quadrants 1 and 2 can have angles with the same sine. Okay, so quadrant 2 contains angles that are beyond 90 degrees. Okay, so what happens when you're using law of sines to find one of these remaining angles, A or C, is it's going to give you, when you use your calculator, it's going to tell you it's from quadrant 1. But it might be from quadrant 1 or quadrant 2 unless you do one thing. And that is, when you look at these two remaining angles here between A and C, okay, can either of those exist in quadrant 2? In this triangle as a whole, the largest side is opposite the greatest angle, right? So are A or C, are either of these the largest angles? Opposite 60, opposite 57, this one opposite 64. No, you know that B is the largest angle, right? So in this case, it doesn't matter which angle you find first. However, if this, let's say, had been 67 here, this side length, then A would be the largest angle. What you want to do is make sure you do not find, or don't use law of sines to find the larger angles. Always use it to find the smaller ones. So what my recommendation would be in a problem like this, after you find your initial piece of information and you're being asked to solve for the unknown angles, find the smaller of the two remaining angles first. That's guaranteed. It will never fall in quadrant 2. It's never going to be an obtuse angle. So if I was looking at these, which angle would I find first? I'm going to find A first. I know it's the smaller angle, so it can't be obtuse. So when I use law of sines to find my next piece of information, I'm finding A. So A over the side opposite it, or sine of A over the side opposite it, is equal to my known ratio, which is now this, sine of 67 degrees over this measure that I just found. And now, I am going to use this measure in my calculation.
And the way to get that into your calculator so you can access it, I'm just going to hit enter. I'm going to scroll up and highlight this. So I go up, highlight it, and then I'm going to delete all my my negative value. Two ways to delete. You could just hit backspace for each of them. You could go to the point where you want to clear everything to the right of it and hit the clear button. That's fine either way. So I'm just going to enter this, and when I hit enter, this is now in a place where I can go and access it anytime I need to. So I'm just made sure that I can access this number as the exact value and not the approximate. And so now when I do my calculation here, remember, if I'm finding a variable embedded in a trig ratio, I'm not going to use the solve feature of my calculator. I'm just going to kind of calculate it out on the calculator. So sine of 67 divided by this measure, I'll highlight it, times 57, hit enter, and I get my ratio, 0.8119. So I know if I want to find A is going to equal the inverse sine of that ratio. And so back to my calculator, take the inverse sine of this ratio, and when I do, I get my answer of 54.28. So there's my angle A. And then the final step, in order for me to find angle C, what do I know has to be the relationship between all these angles? So I can use the triangle sum again, 180 minus the known given angle, 67, minus the angle I just calculated, 54.28, and that's going to give me 58.72. And so those would be my measurements.